Hello and welcome to Maths with El Profelo. In this video we're going to be doing a couple of proofs or proof type questions involving the Legendre symbol. And just as a recollection, that if we let P be an odd number and let an odd prime number, and we let A be an integer with P not dividing A, right, then this Legendre symbol, denoted as these parentheses with A, a vinculum, and a P, is evaluated as the Legendre symbol of A modulo P equals 1 if A is a quadratic residue modulo P, and equals -1 if A is a quadratic non-residue modulo P. Okay, so we're going to use this theorem, theorem 4.6, to help us out of it. And that's going to be that if we let P be an odd prime number, then -1, right, will be a residue, a quadratic residue modulo P if P is equivalent to 1 modulo 4, right, and it will be a quadratic non-residue modulo P if P is congruent to 3 modulo 4. So in other words, trying to say, hey, is it possible to have a remainder of P minus 1, or a quadratic remainder of P minus 1, right, for some odd prime number P? Okay. So let's see how this can be used here. All right, so we want to prove that there does not exist an n in the set of positive integers such that 7 divides n squared plus 1. All right, so this is a symbolic representation that we could have. You know, might almost look like hieroglyphics to us if we haven't used these symbols before, right? But in other words, we're saying is that there does not exist a positive integer n such that n squared plus 1 is evenly divisible by 7. Okay, so what might we do in approaching these problems? Okay, so like I said, if we want to prove that there does not exist, right, an n in the set of integers, right, such that 7 divides n squared plus 1, let's reframe it as following, right? Does there exist a k in the set of integers such that n squared plus 1 is equal to 7k, right? So this is an n, right? So we're saying, hey, if 7 divides n squared plus 1, that means that n squared plus 1 can be written as a multiple of 7k. So we're saying, is this possible? Can I have n squared plus 1 equaling 7k? Right? So therefore, right, is there a solution to n squared is equivalent to -1 mod 7, right? So in other words, right, is 6 a quadratic residue modulo 7, right? Is 6 a quadratic residue modulo 7? Right, now what's useful for us is, because of this theorem involving -1, rather than ask if 6 is a quadratic residue modulo 7, we'll work with -1. So here's how it can work, right? The Legendre symbol of -1 modulo 7 is going to be equal to -1 because 7 is congruent to 3 mod P. Right, so therefore, no n exists such that 7 divides n squared plus 1. Right? So a fairly short proof, fairly short explanation. Let's just work through this information again. So we've got this theorem that says that the Legendre symbol of -1 modulo p, where p is an odd number, will equal 1 if p is congruent to 1 modulo 4, and it'll equal -1 if p is congruent to 3 modulo 4. Right? What does this mean for us? What this means is that -1, right, the Legendre symbol of -1 modulo 7 will equal -1 because 7 is congruent to 3 modulo p, and this is by this theorem 4.6. Right? Well, what does that mean to us? That means to us that 6 would be a quadratic non-residue modulo 7, which means that -1 is a quadratic non-residue modulo 7, which means that n squared plus 1 cannot equal 7k, so therefore we might say, therefore 7 does not divide n squared plus 1 for all n in the set of integers, right? And I should have this word right here, should be that. Okay, so, and really we could, right, we could expand this off beyond the positive integers, but this is the idea, right, that there does not exist, right, any n where 7 will evenly divide n squared plus 1. So this is kind of an approach to a proof type problem, and in our next video we will determine if there exists an n in the set of positive integers such that n squared plus 1 is evenly divisible by 13. Okay, this has been Maths with El Profelo. Thank you for your time.